I am KRISHNAVENI, going to present my research work, Novel Optimization Algorithms for Medical Images, Segmentation and Classification, under the guidance of Dr. R. Shankar Sir, Assistant Professor, Department of Computer Science, Chikana Government Arts College. Before I am going to present my research work, first I would like to welcome our Almighty to my Viva's presentation. Next, it is my privilege and honorably offered my grateful thanks to University nominee and also principal in Chikana Government Arts College, Dr. V. Krishnan Sir. Next, I would like to welcome external examiner, the most respected Dr. B. Surendran Sir, Associate Dean, Academic, Department of Computer Science and Engineering, National Institute of Technology, Puducherry, Karaikal. I welcome you, sir. Next, I welcome to subject expert, Dr. Sridevi ma'am, Assistant Professor, Department of Applied Maths and Computational Sciences, PST College of Technology, Coimbatore. I welcome you, ma'am. Next, I would like to welcome my head of the department, Dr. A. Geeta ma'am, Assistant Professor and Head, Department of Computer Science, Chikana Government Arts College, Tirupur. I welcome you, ma'am. Next, I would like to welcome my motivator, Dr. S. Duraisamy sir, to my Viva's presentation. I welcome you, sir. Next, I would like to welcome Dr. E.R. Karthikeyan sir to this wonderful Viva's examination. I welcome you, sir. Next, I would like to welcome all the professors in the Chikana Government Arts College and also other colleges. I welcome all of you. And next, I would like to welcome my research scholars, my friends, and also my well-wishers. Once again, I welcome you all to my Viva's presentation. Today, my agenda includes introduction about nature-inspired computing, bio-inspired computing, optimization, meta-heuristic algorithm, and image segmentation under the literature review studied to make the overall framework of the research work. It is give the prominent result analysis ended with conclusion and future enhancement. So my motivation of this research work is health is wealth. Health is considered as the most important and also precious for every human being. So we concentrate and also securing the human being from the diseases. So breast cancer is considered as the second leading cause cancer of women in the United States after lung cancer. So it is considered as the global issue to solve in the earlier stage. So in order to improve the breast cancer outcomes and survival, early detection is critical. So we reduce the mortality rate using some bio-inspired algorithms is required. According to National Cancer Institute, in the current year, every 13 minutes, a woman dies from the breast cancer. In 2020, World Health Organization gives some statistical data, 6,84,996 deaths from the breast cancer globally. In 2022, American Cancer Society provides the statistics, and also it is approximately estimated that 43,250 women and 530 men will die of breast cancer. So inspired motivation comes from this view. Then introduction about bio-inspired computing. Bio-inspired computing, we consider three terms: biologically inspired computing. Biological includes the study of both the life of human and animal. Inspiration comes from the nature, and computing, there are two types of computing: classical computing and bio-inspired computing. For classical computing, example is number crunching. So it is called as an interdisciplinary field because it connects the computer sciences with the natural sciences. It investigates models and computational techniques inspired by nature only. So the main aim of bio-inspired algorithm is to develop new computing techniques through natural behavior to solve the complex problems. So complex problems means we can get the two types of solution. The first one is feasible solution. The second one is optimal solution. Feasible mean approximate solutions. Optimal mean best solution. So here optimization concept is used. It is applied in all the related fields, but not limited to constrained and unconstrained engineering problems, machine learning applications, enterprise processes, mechanics, digital marketing, transportation, smart decision making, image processing application and estimation of cost. So here image processing applications are used for my research work. Optimization refers to locating a suitable, most prominent solution to the problem. So main target is given the best solution to the problem. Either we can minimize the constraint or maximize the constraints. So main objective is using segmentation and classification approaches, we can predict the best answer in earlier stages, the main objective. So we obtain the main target to design a new novel meta-heuristic algorithm is designed. So supportive objectives are using duck traveler optimization algorithm, we can identify the optimum threshold value for mammogram image segmentation.
Krishnaveni, start ma.
Okay. Then enhancement image is input to the duck traveler optimization algorithm using multi-level thresholding to find out the optimal thresholds. Then duck traveler optimization using region of interest used to find out the optimal seed points. Then duck cluster optimization using the cluster points. So segmented tumor is easily identified using triple methods. Then segmented tumor whether contain the malignancy or not is obtained by using classification methods such as binary duck traveler optimization and chaotic duck traveler optimization. Then research contributions. So improving the accuracy and detecting the tumor region. Here DDT duck traveler optimization, binary duck traveler optimization, chaotic duck traveler optimization, and improved duck traveler optimization are used. So first research contribution is based on multi-level thresholding. Second research contribution is based on region of interest. Third research contribution is based on k-means clustering. Fourth research contribution is based on sigmoid activation function with binary duck traveler optimization. Fifth research contribution is based on linear discriminant analysis method with chaotic DTTO using segmentation and classification methods. So data set is obtained from MIA's data set, Mammographic Image Analysis Society. It contains 22 images. Normal images 208, benign images are 63, malignant images are 51. It is 1024 into 1024 pixel size. It is all the images are available in portable gray map PGM image format. Combination of both left and right breast images are available. So the important task of image segmentation is mine the secret information from the input images from mammographic image analysis database. The two basic left and right breast combinations lead to MIA's database. The two broad categories are normal and also abnormal. In normal, there are 208 images, and in abnormal, both the benign and malignant images are available. Asymmetry, architectural distortion, ill-defined masses, some circumscribed masses, and microclassification belong to the breast is also identified. Portable gray map image format with 1024 into 1024 pixel image is digitized at 200 micron pixel edge. All the images include the position left and right, and groups, 3 groups, fatty, glandular, and fatty, comes under the subgroups normal and abnormal. It also classified under the benign and malignant. So these are the links for getting the mammogram image analysis society. The mammogram images contain some noise, labels, patient's ID, location of any abnormality. For example, center of the tumor region inside the cancer region. So thus image processing takes important role in image segmentation acquiring the inputting images. So classification is done with the help of Wisconsin dataset features. Binary classing dataset is benign and malignant. Out of 699 samples, class 1 having 458 benign samples and class 2 having the 241 malignant samples. In these classes, totally 10 attributes are extracted. The first one is denotes the sample code number with identification of patient ID. Then star 2 denotes the clump thickness. Then star 3 denotes the speculate uniformity of cell size. Star 4 uniformity of cell shape denoted by star 4. Then star 5 marginal adhesion indicates. Then star 6 denotes the single epithelial cell size. Then bare nuclei denoted by star 7. Blank chromatin denoted by star 8. And normal nuclei called as a star 9, and star 10 specifies the mitosis. So these are the summarization of MEAS category: normal, circumscribed masses, calcifications, speculated masses, architectural distortions, asymmetries, miscellaneous. Totally 161 pairs are available. So totally 322 images are obtained. So first research contribution is based on multi-level thresholding used to segment the images. So thresholding is used to reduces the complexity of the data. It simplifies the recognition and classification. Threshold selection is fully based on the histogram. So grade 2 level of threshold is obtained. The one is black and the another one is white. Then applications of thresholding are: it is a simple method and also effective tool to isolate objects of interest from the background. So document image analysis, logos, graphical content, musical scores are analyzed, map processing, then scene processing, discarding defective parts. In my research work, discarding defective parts, I used the thresholding technique. Multi-level thresholding. Why I am selecting the multi-level thresholding is normal thresholding split the image into 2 regions only. That is called as a gray level image, but we need the several distinct regions for investigation. So I use the multi-level thresholding technique. This technique determines more than one threshold for image. It segments the image into certain brightness region correspond to one background and several objects. So separating an image into foreground values and also background values. Workflow of diagram: input mammogram image, we get the segmented output using objective function Kapur and OTSU'S method. So based on the threshold, maximum threshold value, objective functions are calculated by using both the methods. So it is passed to the input to the duct traveler optimization. Then duct traveler optimization find out the best threshold to segment the tumor region. Then KAPUR'S entropy method. It is called as an entropy method. And also it is the most popular thresholding technique. In this method, the criterion to select a suitable threshold is the maximization of the KAPUR'S entropies based on the gray level histogram. It is based on the entropy and probability distribution of histogram to find out the optimal threshold value denoted by T, which maximizes the overall entropy. The entropy of an image measures the compactness and separability of the classes are obtained. When threshold value approximately separate the classes, the entropy will be the maximum value. These are the equations for calculating the KAPUR'S entropy. These are the KAPUR'S entropy for 2-level threshold algorithm. These are the equations for calculating the multi-level thresholding based on the KAPUR'S entropy method. Then OTSU'S between class variance method. Nobuyuki Otsu is introduced Otsu's method. It is a very popular method and also simplest form. It returns the single intensity threshold that separates the pixel into two classes. That is called as a foreground class and background class. Pixel values that are less than or equal to threshold means it is background. Otherwise, it is called as a foreground value. So these are the equations for calculating the Otsu's threshold, Otsu's between class variance method. Then probability density functions also calculated by using the Otsu's between class variance method. So DTO based multi-level thresholding segmentation mainly focused on KAPUR'S and Otsu's method. So based on those methods, multi-level thresholding is applied to duct traveler optimization. Then final output image is obtained. Similar behavior of duck and traveler, adaptiveness, attitude, abstract thought, appreciation, and ready to go to get the results. So food foraging by duck flocks are, this picture clearly shows the how well organized duck flock to foraging activity. So here mother duck guide the ducklings to foraging activity. So food searching activity is done by the total duck flock in a very disciplined manner. So it is the inspiration for making the duck hunting algorithm. So here duck population comprises of several groups, each group containing a number of ducks that optimizes the food search activity using their stack of intelligence. Then task 2 is based on the height of the neck plus head, the duck obtain the food source. Then they traveling as a flock and follow their local guide which has fed on most food in the last location. So after a number of tasks, duck return on a surface with its local affiliates via communication of exploitation and exploration. So these are the mathematical formulas used for making the duck traveler optimization algorithm. Here duck's position and also velocities are calculated for making the food foraging activity. So the initial locations of duck traveling algorithm are uniform distribution within lower and upper bounds. The fitness values are also calculated. So these are the formulas for making the duck traveler optimization algorithm. Then this is the algorithm. First initializing the duck position, then duck velocities and iterations, fitness function, and also random values. Calculate the objective function for each duck pair. Then find the best duck using DP best value, while threshold value maximum means then for I equal to 1 to I less than n plus 1, we calculate the R value. Update the position of current swimming duck is updated and also velocity also updated. So calculate the objective function using duck pair, update the C values and find the best duck position. So it is the algorithm. Then these are the algorithm for multi-level thresholding. Input mammogram images, initialize the objective function using KAPUR and OTSU'S method, then height width calculated using histogram and filter image, then initialize the DTO algorithm with parameters, problem dimensions D and objective function F. It optimizes multi-level threshold values, KAPUR'S and OTSU'S method by DTO algorithm. Convert the enhanced image using the optimum threshold to get a grayscale image. So output will be the segmented images. So we can using the best threshold values and its corresponding objective values for duck traveler optimization, particle swarm optimization, and genetic algorithm for various images. So these are the basic input mammogram images, combination of left and breast images. So mammogram image contains some noise, high density, low density, label, pectoral muscle, and also breast region. So pre-processing is needed to clear all the irrelevant features. So background removal is one of the technique to removing the background. So pectoral muscle suppression also. If the non-zero pixels are more in the left half portion, then the image is left oriented. Yes, the image is right oriented. After choosing the seed point, seed region growing image segmentation method is applied to remove the pectoral muscle. So contrast limited adaptive histogram equalization, that is CLASSIFIER method, is used to enhance the quality of an input mammogram image. So these are the output getting to apply the CLASSIFIER method. So original image, then it is transformed image, then artifact removal image, and also vectoral removal image. Then CLASSIFIER method and also gamma corrected method is applied to get the clear picture. Then pre-processing image and its corresponding histogram image will be calculated. So histogram of an image refers to a histogram of the pixel intensity values. The histogram is nothing but a graph. It's showing the number of pixels in an image at each different value found in that image. So original mammogram image and different types of histogram images will be obtained. Uniform flat histogram, Rayleigh bell-shaped histogram, curved histogram for MDB 010 image. Then MDB 058 original mammogram, uniform flat histogram, and Rayleigh bell-shaped histogram, exponential curved histogram. Then OTSU'S fuzzy Siemens and OTSU'S entropy methods are applied for all the mammograms. Then it is the output for two-level thresholding values and their corresponding histogram values. This is the example for threshold value 67 and 168. Then three-level thresholding values and their results are shown in the graph. Then four-level thresholding values and their results. Then five-level thresholding values and their results are plotted. So this research contribution is carried out to segment the unusual regions in mammogram by applying Dept optimization algorithm. So next research contribution is improved DTO algorithm for breast tumor segmentation. In our previous research work, we can only find out the several distinct region, but we couldn't find the tumor region exactly. So we need the improvement in Dept optimization algorithm, and also automatic seed region point calculation is very useful to predict the tumor region easily. So IDTO mathematical formulations are obtained by using random walk. So these are the equations to making the IDTO algorithm. Then speed greater than distance, then only capturing the prey in the minimum time. So S greater than D equal to P. Then force also calculated by using the M into A. M is used to denote the duck weight, and which is used to calculate the distance divided by time squared for updating the speed. So IDTO algorithm here, we can give the condition greatest and also warning robustness arbitrary. So D1 and D2, we can split the two groups. So randomly we can pick the duck group, but based on the robustness value. So we can store the best duck group. So region of interest method. So it is mainly used to detect the exact tumor in the region. So in medical imaging, the boundaries of the tumor may be defined on an image for the purpose of measuring its size. So the ROI is the cropping of the required region from the breast images. Then the concept regarding the seed point selection is that the tumor, the high density pixels value. So automatic seeded region is calculated using CASRG because the seed points are considered with higher density. The algorithm not only gives the information about the number of seed points, it also provides the exact position for the seed points, which helps to predict the image, segment the tumor, and also give the accurate results. So applying the pre-processing step on initial data set collected from the MIAS data set, then dividing the images into histogram bins. So every bin shows the intensively the number of pixels and also number of seed points. If any bin does not have any of the pixel values, then it is ignored. Then conversion of the contrast adjusted image using CLASSIFIER method into binary image division of the image into different intensity regions, white and black. As a result, the black region is less than the threshold value and the white region is more than the threshold value. Then implementing a morphological operations like erosion, dilation, opening and closing are applied for again enhancing the quality of an image. For finding the connected regions in the processed image, neighbor pixels are used. So the centroid value of each bin is found with property measurement in image region. Then checking the number of centroid generated by the above predicted, transferring the bin value, number of pixels in the bin, and centroid processing. Finding the minimum density to maximum density region for bin values. then generating number of seed points. The centroid of every seed point having density above some predefined value is considered. So naive Bayes regression classifier is also introduced to selecting the best relevant feature. It is used because it is the simple and also easily implement the classifier. So here the constraints are enlisted in the following equations. 0 means duck group less than or equal to duck flock of K. D lifeless less than or equal to D high value. So where D lifeless is the departed food forage and storage state, and D high is the greatest storage capacity of the duck flock. So these are the results obtained using CASRG algorithm. So mammogram input image is noise image. So anisotropic filtering is applied, then deleting the background image, then breast and muscle image only obtained, then breast image only applied, then tumor region is predicted. So these are the results. So confusion matrix also used to get the accuracy of the classification results. So true positive, true negative, and false positive, and also false negative. So right predictions by naive Bayes classifier is 230, and improved DTO algorithm finds the 242 correct classifications. And faulty predictions, naive Bayes gives the 92 faulty, and also IDTO predict the 80 faulty only. So the accuracy of naive Bayes is 84%, IDTO is 92.5%, and also recall precision F measure values also increased rather than the naive Bayes classifier. So these are the results compared with the naive Bayes and IDTO algorithm. So in this research work, improved DTO algorithm was used to predict the exact tumor region, but research contribution 3 is used to again improving the segmenting the tumor using duct cluster algorithm. These are the example picture in the ducts in the cluster. So for improving the improved DTO algorithm, we can use the duct cluster optimization algorithm. It is utilized and segments the tumor region using K-means clustering algorithm to calculate the cluster values. So duct cluster optimization is inspired by the behavior of the duct cluster in duct traveler optimization. It can be emulated in main characteristics named tolerance behavior. So duct having the capability of tolerance chillness of the cold water in long time. So K-means clustering algorithm is an unsupervised algorithm. It segments the interest area from the background. So it easily split the cluster values based on the centroid values. So the algorithm is used when user have unlabeled data, so without defined categories or groups. So input mammogram image is noise image, then median filter is applied, then K-means with ant colony optimization, K-means with particle swarm optimization is applied, then K-means with duct cluster optimization is used to duct cluster segmentation. Then finally we get the output segmented image. So these are the duct cluster algorithm. So these are the results obtained using duct cluster optimization algorithm. So label removed image, then clustering the similar region in the tumor part. So it can be plotted using graph. So this research work is carried out to segment the tumor by using duct cluster with K-means algorithm. In utilized DCO algorithm, optimally clustered values are calculated efficiently and desired tumor region put properly segmented. So next research contribution is introduced binary duct traveler optimization algorithm for selecting the best feature using BDTO, binary DTO algorithm. For classifying the segmented cluster region, BDTO with sigmoid activation function is applied to classify whether the tumor is benign or malignant. So independent problems are solved by metaheuristic algorithms in either following way: single objective or multi-objective. It is either maximization or minimization. It is quantitative or systematic. It is static or dynamic. It is deterministic or stochastic, local or global, with memory or memoryless, greedy search or iterative search, parallel solution or neutral solution, naturalized or hybridized. So in BDTO, threshold values are precisely tuned to reduce the response time while accuracy. BDTO is a variant of basic duct traveler optimization algorithm based on swarm intelligence using duct flock. It is mainly influenced by duct's tolerant and also imprinting behavior because duct easily identified their siblings easily and also quickly. So the first method of duck flock is saving their offspring from predators by using imprinting character. Then the second mechanism is to find out the food place by using dynamic behavior. The basic two principles of swarming are exploration and exploitation. Exploration means we can search the new solution, that means unpredicted solution. Exploitation means we can use the solution in our hand. So the static behavior of duck flock exhibits in an exploration and the dynamic exhibits in an exploitation field. Both of them are used for select the optimal features for find out the cancer region using binary DTO algorithm. Then an enormous quantity of dynamic
எனக்கு ஏதாவது வந்து இருக்கு இந்த உயிரை இந்த மாதிரி ஆமா அதனால
Krishnaveni, continue, ma.
Okay, sir. So feature selection using sigmoid activation function. It is also called as a logistic regression function. It is used to the mapped to two discrete classes, either benign or malignant. In this research contribution, the given input mammogram is benign or malignant is predicted by using the sigmoid activation function. So feature selection using sigmoid activation function. Clear predictions through gradient smoothing gives the values between the 0 and 1. So metaheuristic with binary or chaotic performs role play to minimize the false positive rate and also decrease the data dimensionality, decline the cost expensive and maximize the accuracy for best optimal feature selection and extraction. Then overall prediction using confusion matrix is obtained predicted values and also actual values. It is classified as positive and also negative. So classification results are class A, B, C. Class A means normal image, B means benign, C means malignant image. So evaluation analysis, accuracy, sensitivity, specificity, F1 score, misclassification, precision and recall also obtained. So accuracy, all of us known as accuracy is the exactness and also essential classification metric suited for best well as multi-class classification problem. So it is a proportion of true results among the total number of cases examined. So accuracy obtained by using the equation true positive plus true negative divided by true positive plus false negative plus true negative. Then sensitivity, it is the ratio of correctly predicted positive observation from the total observation in actual class. So sensitivity or recall is a valid choice of evaluation metric when we want to capture as many positive as possible. Sensitivity formula is true positive divided by true positive plus false negative. Then specificity, it is the ratio of correctly predicted negative observation, total observation in actual class. It is also known as true negative rate. So specificity equal to true negative divided by false positive plus true negative. Then precision measure is calculated by using the true positive divided by true positive plus false positive. It is the ratio of precision. It is calculated as the number of true positive divided by the total number of true positives. So recall, it is the it refers to the percentage of results which are correctly classified. Ratio of precision is calculated as the number of true positives divided by the total number of true positives and false negatives. So these are the equations for calculating the recall value, true positive divided by true positive plus false negative. Then F measure value is calculated by using F equal to 2 into precision into recall divided by precision plus recall. Then this is the accuracy, precision, recall, F measure and sensitivity obtained by the proposed method. Then comparison between sigmoid activation function, duct traveler optimization and binary duct traveler optimization. So this research contribution is carried out to classify the category of tumor regions in mammogram by applying binary duct traveler optimization algorithm. So here comparison results shows that the introduced binary duct traveler algorithm having the high accuracy rather than the sigmoid activation function and duct traveler optimization. Then final research contribution is chaotic duct traveler optimization algorithm for selecting the best future for classification. So for classifying the segmented tumor region in this research contribution, chaotic based duct traveler optimization algorithm with linear discriminant analysis method is introduced to classify the tumor is benign or malignant. So in this manner, both the chaotic DTO and linear discriminant analysis are considered as good methods for solving nonlinear operations as well as categorizing tumor of an image in normal, benign or malignant. So in the course of recent many years, chaotic theory is very popular and also applied in mathematical. Choosing the most discriminant highlights is a difficult issue in numerous applications. So bio-inspired computing calculations also incorporate to giving the prominent solution. So mammogram images from MIA's dataset, then feature extraction from wavelet families, then LDA classifier and chaotic DTO classifiers are introduced. Then classified the image is done by using both of the classifiers. Classification using LDA. So it is introduced by Roland A. Fisher in 1936. It is a simple, mathematically robust and produced whose accuracy is good as more complex method. It is also considered as a supervised and computes the linear discriminants that will present the axis that maximize the separation between multiple classes. So the goal of linear discriminant analysis is maximizing the distance between mean classes and minimize the variation within each classes. It is a dimensionality reduction technique. It is used as a pre-processing step for pattern classification and machine learning applications. LDA is similar to principal component analysis, but LDA in addition finds the odds that maximize the separation between class. If figure shows the before LDA and after LDA. So classification using chaotic DTO. These properties have been mean to different conditions which are called chaotic guides. In this way, utilizing these guides to refresh arbitrary factors in enhancement strategies is called chaotic optimization algorithm. So chaotic groupings have obviously confounded behavior and also it sounds arbitrary development. They are nonlinear frameworks. They are delicate conditions. Because of the non-redundancy of chaos, it can complete in general hunts at higher rates than stochastic inquiries. So finding by the duck plots. Then classifiers, LDA classifiers, it is true positive, false positive, true negative, false negative, and chaotic duck traveler optimizations. Wavelet features are obtained from the wavelet families. So comparisons between the proposed method CDTO with various authors introduced in various years. So it is obtained CDTO having the high accuracy 98.2%. So performance of LDA classifiers are plotted using the graph. Then CDTO classifier performance are shown in the graph. So this research work is carried out to classify the category of tumor regions in mammogram by applying chaotic duct traveler optimization algorithm. All the existing algorithm compared with the CDTO and obtained CDTO having the high accuracy rather than the all the existing algorithm. So results are predicted by using the segmentation methods, 3 methods, multi-level thresholding, region of interest, and K-means algorithm. So all the results show that K-means algorithm gives the best results. So these are the results. Then evaluation, accuracy, precision, recall, and F measure results value with DDSM and MIA's dataset. Then comparison result with existing and also our proposed algorithm DTO, PDTO, and CDTO algorithm. Then comparison performance results are shown in the graph. So conclusion is, in this research work, multi-level thresholding techniques for segmenting the cancer regions are discussed. In optimization techniques inspired by SWAM intelligence to introduced the new meta-heuristic algorithm called duck traveler algorithm. According to this, Kapur DTO and OTSU'S DTO methods are used to predict the optimal threshold values. Then OTSU'S methods are also used to find out the maximum threshold value. So satisfactory results are obtained. So region of interest method also discussed. K means it is also segment the tumor based on optimal cluster value. Then BDTO and CDTO for giving the best classification method. Both the segmentation and the classification is achieved using various bio-inspired algorithm. So this work mainly integrates the duck traveler optimization, binary duck traveler optimization, and chaotic duck traveler optimization to provide a framework to predicting the breast tumor in the earlier stage. Mainly contribution to segment the tumor, either desired tumor region, and classify the tumor normal, benign, or malignant is the main contribution of my research work. Then future work, we are interested in working on a complex data sets and also improving the accuracy of the model will be our major future concern. In order to improve the accuracy, various types of algorithms like BDTO and CDTO are used and also improved in the future. As a future work, we shall also extend our work using improved CDTO with different data set, introducing a hybrid DTO algorithm also used to minimize the error rate. So these are my publications. And these are references used for my research work. Thank you, one and all.
Audience, any queries? Please raise your queries.
Good morning.
Good morning, sir.
Okay, first, the really nice, wonderful presentation by KRISHNAVENI.
Okay, sir. Thank you, sir.
Okay, and my some observation. Apart from the K-means clustering algorithm, there are few more recent algorithms are available, right?
Yes, sir.
And finally, you have come to the conclusion that K-means algorithm is giving the exact or the accuracy அப்படின்னு சொல்றீங்க இல்லையா?
ஆமாங்க sir.
Why?
Sir, many of the existing research work I have studied, and also it predicts the K-means algorithm is best, means it gives the centroid value, correct clustered values using centroid base. So it is the best classification method.
Okay, good. Then what is the data set? எவ்வளவு data எடுத்துட்டீங்க? Data.
Sir, I use the MIA's data set and also Wisconsin's data set and also DDSM data set for processing, sir.
Okay. Volume of data set?
More than 900, sir.
Okay, so more than 900 means அது எவ்வளவு வேணாலும் போலாம் ஒரு
போலாம். Yes, sir.
இல்ல நீங்க எவ்வளவு எடுத்துட்டீங்கறதா more than 900 ன்னு சொன்னீங்கன்னா அது எவ்வளவு வேணாலும் எடுக்கலாம் இல்லையா?
Yes, sir. 950 images, sir.
Okay. So very good. So nice presentation. Congratulations. Okay.
Thank you,
so you are the guide and all, right?
Okay,
okay,
sir. Thank you.
okay.
Thank you, sir.
Thank you, sir.
Congratulations, KRISHNAVENI.
Thank you, ma'am.
Few observations also.
Okay, ma'am.
Similar to the question raised by our previous staff, Dr. Karthikeyan sir, I just want you to go to slide number 60, ma.
Okay, ma'am. Slide 16. 16, sir.
60, ma.
Yes, ma'am. 16, sir. Yes, ma'am.
Right click பண்ணி go to இருக்குலமா, go to போனேன்னா you can go to the straight away, you can go to slide
Yes, ma'am.
60.
I have the
yeah. Here you have mentioned out of 699 samples. So
yes, ma'am.
You are saying 900 samples, but here you have mentioned 699 samples.
Yes, ma'am. This only for classification 699 samples from Wisconsin data set, ma'am. Then I used
ma'am.
Via's data set 322 images, ma'am. I was shown in the table, ma'am. Summarization of Via's data set 322, ma'am.
Okay, so for a research, what is my recommendation and what I would like to kindly draw your attention is
Yes,
you
ma'am.
should have a voluminous amount of data set
Okay,
because
ma'am.
based upon the data set, our results may vary. So
Okay,
data
ma'am.
sets play a very important role and your area of research is data mining. Am I correct, ma'am?
No, ma'am. Area of research is bio-inspired computing, ma'am. So my
Okay,
application is image processing, ma'am.
Okay, so volume of data plays a
yes,
very
ma'am.
important role
I
in
use-
all the experimental results.
Yes, ma'am. Okay, ma'am.
Even if you say 1000 or 1500,
Yes, okay,
my
ma'am.
humble suggestion is it is not recommended for an experimentation where you are going to concentrate on a life taking issue of predicting a cancer tumor.
Okay,
So
ma'am.
in that
Okay,
case, accuracy is very important.
yes, ma'am.
Okay, so because it is for a life saving purpose. So
Yes,
on the
ma'am.
volume of data set, it plays a very important role in the working of the algorithm. Okay, ma'am.
Okay, ma'am. Okay, ma'am. Okay,
So in
ma'am.
your future
Yes,
endeavors,
ma'am.
you can see
Definitely,
that
ma'am.
you have
So all are
voluminous amount
please,
of data
ma'am,
set
Geeta ma'am,
so that you are
1 second. All are please rejoin. Zoom time is out. Please rejoin. Please. Sorry.
no issue.
Okay, ma'am.
Am I audible, Krishnaveni?
Yes, ma'am.
You can start sharing your screen, ma'am.
Yes, ma'am.
Ah. Sir, please raise your questions.
Krishnaveni, are you going to slide number 143, ma'am?
Yes, ma'am. Screen. Yes, ma'am.
Yes, sir. And can you say from the images, ma'am, what is those colors represent? Because you have mentioned only 2 types of tumors.
Yes, ma'am.
What it represents, ma'am?
Ma'am, it represents the red represents malignant tumor, ma'am. And violet represents the normal, ma'am.
Okay.
And the orange represents the benign, ma'am. And the light blue also normal.
But
I
you just
can
look into
use
it, ma'am. So that you have to put down
Yes,
description what those colors represent. Okay, then
Okay.
only it will be easy for the
Yes, ma'am. Okay,
others
ma'am.
to understand.
Yes,
Similarly,
ma'am.
in slide number 155, ma'am.
155. Sir, 155. Yes, ma'am.
Okay, so what is the difference between those performance measures, ma'am, the accuracy, sensitivity? Can you throw some light so that other researchers can also follow?
Yes, ma'am. I finally shows the all the performance metrics compared with already.
You are not audible, KRISHNAVENI.
Yes, ma'am.
Okay, very good work, KRISHNAVENI. Congratulations to the supervisor and the scholar. Thank you, ma. Please carry
Thank
on.
you, ma'am. Thank you, ma'am.
Please raise your questions. Anybody? Sir, Surendran sir.
Hello.
Sir.
Sir, audible, sir. I am audible.
Yes, sir. Yes, sir. Audible.
Okay. What a good presentation.
Sir, thank you, sir.
Yeah, you explained very clearly and without any questions. You have done a very nice work.
Yes, sir.
So, based on your presentation,
Yes, sir.
why multi-level threshold is required?
The normal thresholding, we only apply the gray image, that is black and white image. But we applying multi-level thresholding, we can get the several distinct regions, and also apply multi-level thresholding. It can easily converted to any format, sir, any image format. That's why I multi-level thresholding technique, sir.
Okay. Then whether high PSNR value or low PSNR value is good?
Sir, high PSNR value is the good, sir, because formula also PSNR value in the denominator only. So denominator says that MSC will be the low. So high PSNR value is the
இது அந்த மறுவரையறை இருக்குங்க.
What does PSNR signify?
அதுக்கான இதுதான் கருத்து கேட்டுதான் மக்கள்.
Sir, it signifies the how much the image obtain the peak level, sir.
கோயம்புத்தூர் பதிவு மாவட்டத்தில் அடங்கிய மொத்தம் 313 கிராமங்கள் எல்லையை கீழ்கண்டவாறு வரையறை செய்து பதிவாளர் குறித்தும் பொதுமக்களின் கருத்து கேட்டு போட்டோம். இந்த வரையறையில் ஏதாவது உங்களுக்கு என்னை வந்து இருகூர் வந்து சூலூர் கொண்டு போக வேண்டாம், வேலூர் கொண்டு போக.
Tirunakasi sir, kindly mute sir. Okay, and so how many images are used?
So totally 950 images, sir.
Okay, what is the training testing ratio for your classifier?
Sir, training 70%, sir. Testing 30%, sir.
Okay, have you tried with any other ratio or only this ratio?
Only this ratio, sir. Because volume of data is 950 only. In future, I will apply to change the ratio also, sir.
Okay, how many features are used for classification?
Sir, totally 10 attributes are selected, sir, from the Wisconsin's data set. For example, clump thickness, mitosis, that 10 attributes also considered for extraction, sir.
No, you use feature selection, correct? Before feature selection,
Yes, sir.
how many features?
Yes, sir.
After feature
Wavelet
selection, how many?
features. Yes, sir.
Okay. No, wavelet features, before feature selection, how many features are there?
16 features, sir.
But the wavelet will get more features, correct?
Yes,
only
sir.
16.
Yes, sir.
Only 16 you have used.
Yes, sir.
Okay. Okay. Why random index is required? What is the purpose of it?
Sir, it is currently mainly it is used for segmentation purpose. It correctly selects the correctly paired cluster values, sir. So I use the random index. It contains the two values, 0 and 1. 0 means no pair, 1 means correctly classified pair, sir. So I use the random index value,
Okay,
sir.
how many clusters you have used?
Sir,
Number of clusters?
the number of clusters 2, sir.
2. Why only 2?
Sir, because we need the 2 class only, sir. Either benign or malignant. So 2 clusters are used, sir.
Okay. Okay, well, that's all from my side.
Thank you, sir. Thank you so much, sir.
Thank you, sir. Sir, Surendran sir, declaration.
Okay, sir. So today we witnessed the open Viva voice defense by the candidate KRISHNAVENI A. She had very clearly explained her work and had some good publications. And based on her, and also she also answered the queries raised by the audience and myself. So based on her presentation and her work done, so the committee recommends for award of PhD degree to KRISHNAVENI A. So hereafter she will be called as Dr. KRISHNAVENI A. Congratulations, madam, and to his to her guide Shankar sir also.
Thank you, sir. Thank you very much,
Sir,
sir.
thank you so much, sir.
Shankar,
KRISHNAVENI.
congratulations.
Sir, thank you, sir.
Okay, KRISHNAVENI,
Sir, thank you, sir.
congratulations. Okay.
Thank you, sir. Thank you, sir.
Durai too.
Sir,
Thank you,
sir,
ma'am.
thank you, sir. Sir, நல்லா இருக்கீங்களா? Thank you, sir. Thank you, sir.
Thank you, ma. Thank you, sir.
Congratulations, Shankar and KRISHNAVENI.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.
Sir, any
Sir,
vote of-
congratulations, sir. Madam, congratulations.
Sir, thank you,
sir.
sir.
Thank you.
Shankar sir, hearty congratulations.
Sir, thank
KRISHNAVENI,
you, ma'am. Thank you.
congratulations, ma.
Ma'am, thank you so much,
Sir,
ma'am.
with your permission, let me take leave, sir. Thank you so much, sir. Thank you for all the professors, scholars who have joined for the Viva. Thanks a lot. Thank you so much, sir.
Thank you, ma'am. Demo.
Once
Thank
again,
you.
I thank you, all of you, to attend my Viva's presentation. Thank you, all of you.